Good day everyone. Today I will be presenting the three main methods for solving systems of linear equations. These are Cramer's rule, the inverse matrix method, and the Gauss-Jordan elimination method. I will explain how each method works, when to use them, and their advantages. So a system of linear equations is a collection of two or more equations that contain the same variables. Our goal is to find the values of the variables that satisfy all equations at the same time. In this example, we are looking for the values of x and y that make both equations true. So the example is x plus y is equal to 5 and x minus y is equal to 1. So first, we have the Cramer's rule. It uses determinants to solve a system of equations. It can only be used when the system is square, meaning the number of equations is equal to the number of variables. Also, the determinant of the coefficient matrix must not be 0. To find each variable, we divide the determinant of a modified matrix by the determinant of the original coefficient matrix. First, these are the steps in Cramer's rule. First, we form the coefficients matrix from the system. Second, we compute its determinant. Third, we replace one column at a time with the constants to get dx and dy. Finally, we divide dx by d to get x and dy by d to get y. This method is simple for small systems but becomes complicated for larger ones. Next is we have the inverse matrix method. So the inverse matrix method rewrites the system in matrix form as AX equals B. Here, A is the coefficients matrix, X contains the variables, and B contains the constants. To solve for X, we multiply both sides by the inverse of matrix A. However, this method only works if matrix A has an inverse, which means its determinant must not be 0. So, here are the steps in inverse method. So first, we express the system in matrix form. Second, we compute the determinant of A to check if an inverse exists. Third, we calculate the inverse of matrix A. Finally, we multiply the inverse by matrix B to get the solution of matrix X. This method is powerful, especially when using calculators or computers. So, we have now the method 3, which is the Gauss-Jordan elimination. So, in Gauss-Jordan elimination, it transforms the augmented matrix into reduced row echelon form using row operations. The goal is to make the left side of the matrix into the identity matrix. This method is very flexible and works even when other methods cannot be applied. So here are the steps in Gauss-Jordan. So first, we write the system as an augmented matrix. Next, we create leading ones in each row. Then, we eliminate other numbers in the column to create zeros above and below the leading one. We continue this process until the left sides become the identity matrix. The right side then shows the solution. So, now that we are done discussing the three methods, let us compare those methods. So, Cramer's rule is simple but best for small systems. The inverse method is organized and works well when the inverse is easy to compute. Gauss-Jordan is the most flexible and works even for larger systems, so it is the best one to use. Each method has advantages depending on these situations. So for conclusion, we learned three methods for solving systems of linear equations: the Cramer's rule, the inverse matrix method, and Gauss-Jordan elimination. Each method has its own strengths. Choosing the correct methods depend on the type of system you are solving. So, thank you so much for listening, and I hope you've learned about the three methods in solving linear equations. Thank you very much.